Let's move on to the IMT. So we finished coronary calcium and PAD. We're on time. As far as carotid IMT, we have a distinguished panel as well. Unfortunately, Alan Taylor could not be here, but he's represented by Gene Bond, who is also a pioneer in this field. Gene, your slides are on, and please stay on time.
I've been asked to represent the Society for Atherosclerosis Imaging and Prevention. That was quick, Mark.
Go ahead.
You're done.
Which has several different groups associated with it. One is the Carotid Intima Media Thickness Council, which is chaired by Mark Ohlendorf. Next slide. This particular committee has 3 arms to it, 4 arms: an appropriate use committee, who to measure, when to measure, clinical efficacy of monitoring, change over time in IMT in individual patients, as well as technician training and equipment use. Next slide. And the definition of IMT, broad-based definition of IMT. Next slide. The shaped questions are: can it be used to track disease in individuals? What is the extent of the reproducibility problem? And is there a standardized reproducible acquisition protocol? Next slide. The CIMT Council defines it in different ways. The definition of CIMT is that it's a continuous variable which measures linear distance between the arterial lumen intima and media adventitial interfaces. That is, it's the combined intima media thickness. CIMT and plaque are not 2 separate processes as suggested by several French investigators that consider them completely independent. One is a measurement and it's continuous. It can be used to measure normal arteries as well as arteries that have plaque. So one is a diagnosis, one is a measurement. Next. One of the most confusing parts about this field, and right now there are between 8,000 and 10,000 publications in peer-reviewed journals on IMT since the early 1980s, has to do with where to measure and what to measure. In most studies, it is the distal straight portion of the common carotid artery before the bifurcation. Carotid bifurcation itself, and the proximal 1 centimeter of the internal carotid artery. Confusing the field a bit are some individuals measure near wall, others measure far wall, others measure near and far wall of each of these 3 segments. We know from the work of Solenberg at LSU and Jack Strong going back into the 1960s that atherosclerosis in the carotid, extracranial carotid arteries begins on the wall of the bifurcation that's associated with the internal carotid artery. It progresses circumferentially around this segment in addition to going distally into the internal carotid artery, and lastly, progressing down into the far wall of the common carotid artery. Common carotid bifurcation internal. Which to measure, where to measure. Next. Okay. Last slide. The critical issue is an N of 1. All studies that have been done thus far involve populations randomly selected or populations for clinical trials. The issue is, can this method be extrapolated from research groups into an N of 1? And that's the problem every single one of these methods faces. An important question is what are the goals of the screening protocol? Is it used to estimate CAD risk or stroke risk? Secondly, the goal of serial measurements in individuals. Is this CAD or stroke? 2 different questions, and huge differences between the 2 in the methodology, in particular the reproducibility that's required to do that. To think that one establishes a screening protocol and that's not going to be used sequentially is a farce. Almost every single method, even without the background, and I'm talking about coronary arteriography, is a challenge when you get to an N of 1 because of angle difference, etc. So that's the opening.
Okay. So, can IMT be used to track disease in individuals?
Well, the scientific community is split on that. There are some that definitively say no, question about the reasons, say it's impossible, and walk away from the table.
Okay, we're gonna open the discussions here. Tasneem?
I actually want to touch upon some of this in my work that I'm going to give, but I think it's ready to be used in an individual, provided the interval that you're going to use it in an individual is at least 3 years. I don't think it's ready to be used every year. At least 3 years, 3 to 5 years, in my opinion.
Okay, well, obviously this follows the question of reproducibility. What's the variability? The variability is going to be larger than the progression rate, within whatever time interval, you're not going to get anything out of it. Go ahead.
Can I go to my last slide since?
Yes, we have a little more time on IMT.
The issue
because
has
Steve
come
is not
up
here.
about reproducibility, and one of the significant problems in the methods that have been discussed today, including CAC, has to do with reproducibility.
This is your last slide?
No. And we'll go through it later.
Okay.
There are different ways to measure reproducibility, and what I've heard only is a coefficient of variation. That parameter is inadequate to do quality control. Quality control has to be done with this technique, as it should be done even with CAC, meaningful quality control. So the issues are arithmetical differences, absolute differences, Pearson correlation coefficients. None of those give you the true estimate of variability, and that's something we can discuss. Absolute difference is best. In terms of this technique, absolute difference varies based on whether it's the common, whether it's the internal, whether it's the bifurcation.
But it's the reclassification that's a problem currently because of all the technical issues you raised. If I do a carotid IMT today and I get a value of 0.9, then that puts a person in a different risk category than if I do it again tomorrow and get a number of 1.0. And it's that measurement precision error. It's not a reproducibility, because I'm not going to repeat it ever. Okay, let's just take that off the table for a moment. It's a problem because they reclassify patients into the wrong category of class. I go from normal to abnormal in a day. It's a CRP issue, it's a carotid IMT issue. It needs to be overcome. We need to figure out how to measure it. But there's so many questions after 9,000 publications, I'm just confused as to what I should measure if I do carotid IMT.
So let's go back to the issue that Gene brought up. What are the sources of variability? So what Matt said is a very clinical exam. You measure today's 0.5, you measure tomorrow's 0.8 or 0.7 or 0.6 today and 0.9 tomorrow.
That sonographer and reader combination would be interrogated in almost, not quite all, any clinical study that has used IMT and taken out of the study if they could not be retrained and recertified.
Okay, let's go through your slides. It's each source of variability.
Currently in IMT, there are 3 major sources of variability: patient anatomy and pathology. It's much easier and much more reproducible to evaluate IMT in the absence of atherosclerosis than it is when plaque is present. No different from any other method that looks at plaque. Sonographer variability and reader variability.
Why are you measuring if plaque is present? What does it add? If you have plaque, what do you get from IMT?
The Atherosclerosis Risk in Communities program has shown that the presence of plaque in that study, defined as the upper 25% of the population in terms of these 3 segments combined, increases the risk of having CAD and stroke.
Well, I think what his question is, why do you need IMT when you have a plaque? So I think if you have a way to monitor the progression or regression, and plaque doesn't regress as much as IMT, perhaps there is a reason
But
for...
They're not different, Mort.
Oh, well,
It's
then let's answer his question. Why do
The
we need to
mere
measure
presence of
IMT?
plaque portends a much higher risk than
Right,
any
right.
level
You
you can
become
get
high
with
risk.
IMT.
Right.
Well, you have to consider both extent and severity of plaque, not just is a plaque present or not present. It makes a
The
difference.
Cabas study followed 10,000 people, showed that if you had an IMT above 1, you had an 8.7% event rate, and if you had any plaque as great as 1.5, you had a 39% plaque event
Can we
rate.
go back 2 slides more? This is from a young person coronary carotid artery taken out, pressure perfused at systolic pressure. Normal artery on this side, fatty streak on this side. This is about 0.9 millimeters. Let's go to the next one. This is a carotid endarterectomy specimen from a TIA patient. 6 millimeters in thickness. So it does make a difference how extensive the plaque is, as well as its characteristics.
Well, it still doesn't answer Jeff's question.
Well-
He's saying, why are you measuring? I think, Jeff, when they're measuring plaque, I mean, they got the plaque, the side, IMT measurement doesn't make much of a hassle, so what's the problem
Because it
measuring?
doesn't add a single thing to what you're trying to show. And yes, plaque morphology does add. The lower the, more the hypoechoicness of the plaque, the greater the risk of that plaque. And grayscale medium is used for that. But once you have plaque present, multiple studies have demonstrated that your event rate is so much higher that your fifth quintile of IMT.
Okay.
Yes, the other
So
issue-
you're referring to plaque composition, and if we
I'm
have to
saying
wait
any plaque,
right.
you have a greater risk
Okay,
than at the highest level of
let's hear
IMT.
Emil and then Ernie.
I totally agree with Jeff there. If you have plaque there, it pushes you to the category. So the other thing is you can actually, if you're measuring the common carotid far wall, you can actually have a relative, you can have IMT less than 1.0 millimeters. Actually have a significant amount of plaque in your internal carotid. So you can have, it may not even assess, you got to add the plaque on that. You've got disease, plaque, you've got the disease, you're done.
So be more vigilant towards the plaque, that's what you're saying, but the plaque frequency is not as much as increased IMT, so we have to address that what percentage you can really find plaque. Ernie?
I just say, I think plaque is a strong predictor, but nevertheless, maybe CIMT in the common carotid artery is better to monitor the disease and treatment, because plaque is composed of necrosis, fibrosis, calcification. It does not
Two
ripple.
different questions.
While common carotid artery IMT is composed of media and foam cells, and these components are very regressible, so and very dynamic. So maybe IMT in the common carotid artery may be useful for monitoring the disease and treatment, but plaque is more better for risk prediction.
Okay, that was a very good point. Let's move on to the slide again one more time. We talked about the anatomy in plaque versus IMT.
These are the sources of variability.
source of variability. So if you were to allocate or attribute the percentage of variability practically from high level point of 50,000 foot, which one of these? Sonographers. Sonographer is number one.
That's correct.
That's the first source of variability. Then instrument. We have major issues between instrument. GE, Philips, and
No,
Sonosite.
not really.
No.
Most of those instruments have been used in one or several clinical trials.
Does it matter if it's 12 megahertz versus 7 or something?
Well, the optimum is 8 to 10 megahertz. When you get up above 10 megahertz, the attenuation as a result of that high frequency results in less precise imaging.
Okay. Any other thoughts here on the reader? The manual obviously.
Yes, characteristically.
And
It's
it-
composed, most of intermediate thickness is composed of media. And media depend on hypertension.
That's right.
So it's the kind of lesion you see when you measure intermediate thickness.
So we-
and it's very dynamic, it's regressible. So maybe you can, maybe you can monitor your treatment here.
Okay.
And maybe the plaque composed what we have here.
Okay.
The plaque is the carotid bifurcation, is necrosis, fibrosis, calcification. It's not very dynamic.
Okay.
What is it?
What you showed in the previous slide was a plaque.
Yes, it's a
That's
lesion,
a
it's an
small
early
lesion that-
lesion.
that you're looking at.
It's a
Focal
lesion.
lesion.
Yes, it's a, no, I'm not sure. Maybe you can see it. I don't think it will pass the cut point for a plaque or in the Van Dyke classification. So it's the kind of thing you can see in the common carotid artery. If you also go back here, you can see there is no focal lesion down here. There is some yellow spot here. It's probably foam cells and so on. But there's no major focal lesion here. It's more kind of diffuse disease. So, and it, I also think was what found and present in this paper here, where it was shown when they divided the carotid artery in the common, the bifurcation, and the internal and external and distal bifurcation, there was different risk factors for intermediate thickness. And in fact, the segment that corresponded most to risk factor was thickness in the common carotid artery. And it's strange because it's not atherosclerosis, but maybe it's because it contains feature that is shared with atherosclerosis. It also to me indicates, because common carotid artery intramedullary thickness correlate closely with risk factor, then maybe it does not provide so much prognostic information beyond risk factor. There's probably not so much incremental prognostic value in the common carotid artery because it correlates closely with risk factor. There is a greater potential for additional prognostic information in the carotid bifurcation because it doesn't correlate strongly with risk factor. I think it makes sense in some
The
way.
intimal thickening actually goes on with blood pressure, and blood pressure goes on with age. In a matter of fact, when you look at all the data of intimal thickening, you realize it's an age-dependent phenomenon.
Yeah.
At least these are the studies done with MRI. And goes with age, goes up, and if his blood pressure goes up further. But it is very questionable what this is adding
Yeah.
to what we see with imaging in the focal disease, and what is adding to the risk factor profile.